In this lesson, we will learn about angles. Before we start to learn about angles, let's look at the circle on the left. Each circle is divided into 360 equal parts. So in the figure on the left, if you observe, there are 360 lines, and each line is considered to be one equal part of that circle. And measure of each part of the circle is called a degree. So if you observe on the left, between these two line segments in yellow, there are 45 equal parts, and we represent this as 45 degrees. And we say the angle between these two line segments is 45 degrees. Similarly, you can consider the line segments in the blue, and if you observe, there are 90 equal parts between these two line segments, and we call the angle between these two line segments is 90 degrees. So we have already used the word angle. Let's now define it. So an angle is formed by rotating a ray from its initial position to a terminal position. So if you started at initial position as here and then you end up here, and we call the change of the ray from its initial position to the terminal position on a fixed point O a rotation, and the measure of that rotation is called an angle. And the rays that form the angle are called the arms, and this fixed point O is called vertex. Next we'll learn about different types of angles. If the angle between the two rays theta is equal to 90 degrees as seen here, we call that angle as a right angle. And these two rays are said to be perpendicular. Whereas if theta is less than 90 degrees, we call that as a acute angle. On the other hand, if theta is greater than 90 degrees, we call that a obtuse angle. Theta is equal to 180 degrees as seen here, we call this a straight angle. Whereas if theta lies between 180 and 360 degrees, we call that angle a reflex angle. Next we will talk about pairs of angles. Consider in the figure 1 the two angles. One of them is 70 degrees and the other is 20 degrees. So the sum of these two angles is equal to 90 degrees. Similarly in the figure 2, you observe there are two different angles, and the sum of those two angles is also equal to 90 degrees. So when you have two angles whose sum is equal to 90 degrees, theta 1 plus theta 2 equal to 90 degrees, we call theta 1 and theta 2 as complementary angles. So if someone tells you that theta 1 and theta 2 are complementary and theta 1 is equal to 50, what is theta 2, right? So theta 1 is equal to 50, what is theta 2? And we have given that theta 1 and theta 2 are complementary. So theta 1 plus theta 2 is equal to 90 degrees. Theta 2 is equal to 90 minus 50, which is 40 degrees. So in this way you can calculate the other angle if we know one of those angles. Similarly, if you have two angles whose sum is equal to 180 degrees, then those two angles are said to be supplementary angles. So here in figure 1, the two angles 120 and 60 add up to 180 degrees. Similarly, in the figure 2, we have two different angles, but their sum is equal to be 100 plus 80, which is 180 degrees. So these angles are called supplementary angles. Now let's look at the figure 1 one more time. So the two angles 120 and 60 degrees both have the same vertex A, and they have a common arm. Let's call this B, a common arm AB. So these angles are called adjacent angles. So if two angles have the same vertex and one common arm, those two angles are called adjacent angles. So let's take another example. So in this figure, we observe that theta 1 and theta 2 have the same vertex O and a common arm OB. So theta 1 and theta 2 are called adjacent angles. Now going back to figure 1, we have already discussed that these two are adjacent angles, but This is also a special case where the sum of the adjacent angles is equal to 180 degrees. So those kind of angles are called linear pair. So a linear pair is a pair of angles which are adjacent to each other and the sum of those two angles is equal to 180 degrees. So always a linear pair of angles are supplementary angles, but not all supplementary angles are a linear pair, because if you observe in figure 2, these two are supplementary angles but they have no common vertex. So these are supplementary angles alone, but they are not linear pair. Whereas in figure 1, those two angles are adjacent to each other. The sum is 180. They have a common vertex and a common arm. So these are a linear pair. In this lesson, we will learn about a couple of linear pair axioms. The first axiom states that if a ray is standing on a line, the sum of the adjacent angles formed by that ray and the line is always equal to 180 degrees. So if you observe in the figure, OA is a ray standing on a line BC and it is forming two adjacent angles theta 1 and theta 2, and the axiom states that the sum of these two angles is always equal to 180 degrees. The second axiom states that if the sum of the two adjacent angles is equal to 180 degrees, then the non-common arms will form a line. So if you observe here, OA is a ray standing on a line BC and forming adjacent angles theta 1 and theta 2 with a common vertex O and a common arm OA. The non-common arms are OB and OC. So the second axiom states that OB and OC will form a line, and as you observe here, definitely BC is a line. So the second axiom is actually a converse of the first axiom.